Exploring the origin. Hello, I'm Shuko Chen. This talk pursues the physical nature of spatial dimensions and answers why our world is three-dimensional. The video view comes from the non-mainstream vacuum super theory. Let's start with the relationship between matter and space. Let's look at this picture. As you can see at a glance, the left one is a white sheet of paper and the right one is Leonardo da Vinci's famous painting Mona Lisa. Let's think about this further. What is the difference between a painting and a white background? In fact, the difference is very obvious. The reason why a painting becomes a painting is because a painting has pixels. And we can keep taking away the pixels of this painting. And finally, when there is only one pixel left, this painting becomes a painting with only one pixel. Or there is only one pixel on the white background. But it is this pixel that makes it fundamentally different from the white background. As long as one pixel exists, it can be as long as there is a fundamental particle in the vacuum. The vacuum can be transformed into space, because the particle defines a point in space. And without this particle, space degenerates into a vacuum. When there is nothing, the concept of space loses its material basis of existence. And it follows that space is space because of the existence of matter. Next we come to the second question, the origin of spatial dimension. Spatial dimension is determined by the dimension of the basic unit points that make up space. To make it easier to understand, let's look at this diagram. In this diagram, you can see that one is in black and white and the other is in color. So what determines the color of the picture? If the pixels of this picture are only black and white, then a picture made up of black and white pixels is a black and white picture. If the pixels of the picture are a composite pixel made up of red, green and blue pixels superimposed on each other, such pixels are called colored pixels. And a picture made up of colored pixels is a colored picture. Similarly, in a space, the basic element that constitutes this space is the elementary particle. If this elementary particle is one-dimensional, the space constituted is one-dimensional space. The space constituted by two-dimensional elementary particles is two-dimensional space. If it is three-dimensional elementary particles, the world constituted is three-dimensional. Here more than one sentence. Leaving the material properties directly from the mathematical point of view to say dimension. As a single man talking about a beautiful married life is absurd and ridiculous. Let's move on to the third problem to talk about the dimensional properties of points from a mathematical point of view. Let's recall what we learned in junior high school. Points make up lines. Lines make up faces. And faces make up bodies. This statement is seriously flawed. Strictly speaking, it should be a one-dimensional point that constitutes a line. A two-dimensional point that constitutes a line that can constitute a surface. And a three-dimensional point that constitutes a surface that can constitute a body. Look at this diagram specifically. Consider a one-dimensional point. Imagine we are a one-dimensional intelligent life. A tiny one-dimensional worm, roughly seen as a one-dimensional point. Since this point has only one dimension, we simply cannot escape the dimensional space we exist in. The world that a one-dimensional worm can see is one-dimensional. A one-dimensional worm can constitute a line, since the worm cannot escape the dimension in which it exists. Therefore, a one-dimensional line formed by a small insect can never form a surface. Consider a two-dimensional point. The little ants can move freely on a two-dimensional surface. And after the first line forms a line, a second line is formed, so that there are these two-dimensional points to form a surface. By the same token, imagine that we are three-dimensional intelligent beings. Flying ants with wings. We can move freely on the two-dimensional surface, but also can fly, assuming that many flying ants paved a surface. Flying ants can fly up in the original surface and then paved a layer, and constantly stacked down can constitute a three-dimensional body. Three-dimensional body will extend the concept of three-dimensional volume. Three-dimensional volume of the concept once formed. We can remove all the material in the three-dimensional volume, leaving an empty abstract three-dimensional body, which is familiar to us three-dimensional space. Three-dimensional space of the concept of further abstraction. We are familiar with the establishment of the Cartesian coordinate system. It can be seen that the establishment of the coordinate system to have a material basis. The material basis is the existence of a three-dimensional point in space. This point is the origin of the Cartesian coordinate system. There is a description of the material world of three-dimensional space coordinate system. Imagine that without this point, the three dimensions will have no way to extend outward. Right-angle coordinate space three dimensions have lost the basis of existence. The condition for the outward extension of the dimension here is the existence of a three-dimensional field around the point. And I will talk about this further below. In practice, we will remove this physical point, retaining the three-dimensional property by default. And so we have the abstract three-dimensional Cartesian coordinate system in mathematics. Question 4. What are the properties of dimensionality from a physical point of view? For physics, the dimensionality of a point is determined by the nature of the force field at the point. A field whose strength decays by the square is a three-dimensional field. A field whose strength decays by the 1 times square is a two-dimensional field. And a field whose strength decays by the 0 times square is a one-dimensional field. Refer to the formula in the figure. For a two-dimensional point, imagine a point charge in a two-dimensional plane. The strength of the power line is equal to the number of power lines passing through the circle. And the length of the circle is equal to 2r. The larger the circle, the weaker the strength of the power line, which decays by the negative power of r. For a one-dimensional point, it is easier to imagine that the one-dimensional force field decays by the 0 power of r. In fact, it is a constant, as the interaction between grasshoppers on a rope. After being pulled by a line, the force between the two grasshoppers has nothing to do with the distance, which is the 0 power of r. This is the one-dimensional force field. The force of the rope in the pulley set is also a one-dimensional force field. The fundamental unit of our material world is the atom, and the dimensional properties of the atom determine the dimensional properties of the world. Atoms are composed of charged particles, and it is known from experiments that the electric field strength on the surface of the spherical shell of the electric field of charged particles decays by the square of the distance, satisfying Coulomb's law. In other words, atoms have three-dimensional properties. You will say that atoms are not charged. In fact, this is because the nucleus and the electron outside the nucleus with equal charge. The electron outside the nucleus is negatively charged. The nucleus is positively charged, although the two positive and negative charges cancel each other. But the electrostatic field still exists, just in the superposition of positive and negative electric field state. And the superposition state does not change the dimensional properties. Therefore, the material world composed of atoms is three-dimensional. In secondary school physics class, we will find that Coulomb's law and the law of gravity are very similar. The size of the force is decayed by the square of the distance, indicating that the gravitational field is also a three-dimensional field. We live in a three-dimensional gravitational field, and all perceptions of the external world by our 5 sensory organs are derived from three-dimensional electromagnetic interactions. Therefore, for human consciousness, the world we can recognize is a three-dimensional world, the essence of which originates from the three-dimensional nature of the electromagnetic and gravitational fields. If students still want to pursue the question why the electric field has three-dimensional properties, whoops! I will transfer your question call to God. Let's return to the issue of multidimensional space. The formula of field strength and dimensionality allows multidimensional space to be experimentally tested as Occam's razor of spatial dimensionality. The three-dimensional properties of our world are experimentally supported by Coulomb's theorem and Newton's law of gravitation. At present, the negative nth power field of multidimensional R has not been observed in experiments. It is possible that multidimensional space exists within an extremely tiny scale, far beyond the limit of human experimental detection. And according to Occam's razor principle, if no experimental evidence can be found, there is no need for it to exist, and the multidimensional space-time theory will become a carved and exquisite sky building. Finally, let's conclude that spatial dimension is an extrapolation of the properties of the material field. The three-dimensional properties of space are derived from the properties of electric and gravitational fields that constitute the atoms of the material world. Multidimensional space is not supported by experiments, and over-interpretation of the concept of dimensionality will cause unnecessary troubles to ourselves. That's all the video content. Thanks.